Started. Good afternoon, everybody. I'm going to talk to you about scaling your application tier using AppFabric caching. This project was formerly called Project Velocity. So in between, I might start using Velocity or AppFabric caching. They're one and the same. In fact, we had a lot of people come and ask, saying, what happened to Velocity, this AppFabric caching? Is it something new? No, they're absolutely the same, one and the same. All right. Let's say you have a grocery website that you've built. It's a simple grocery shopping cart. I'm just using some Northman example here, but let's say you have a grocery website. You have a bunch of items in your grocery page. People come there, shop around, add it to their shopping cart, and they go along. Life is great, right? And typically, in such a system, you would have like a two-tier architecture. You have like your web tier with running ASP.NET, IIS, and then you have a database tier that's typically holding all your catalog and other information. You could also put all your session data typically in your ASP.NET local itself so that you have sticky routing that comes to the ASP.NET tier. Now, life's going on great, and then something happens. Let's say the swine flu hits, right? And then people don't want to go to the grocery carts anymore. They want to actually shop online, right? And so what happens? You become a very popular grocer at this stage, and suddenly you have a lot more customers that you can deal with. And things start to happen. Your website starts running slower. Your shopping carts start disappearing because your ASP.NET servers are timing out or crashing because of the load. And you want to push all the load. Maybe you'll try to push them to the database, but then the database starts running hot, right? And at that stage, you want to say, OK, let me buy more machines. But of course, this is recession time. You're not going to get much money for it, right? So what's the solution? Is there a solution for this? And I'm here to announce that, yes, there is one, and that is AppFabric caching. It's a cheesy introduction, but you get the point, right? So AppFabric caching can definitely help you both scale your website. It can help you make your website perform better and also protect against failures. And we're going to see through the talk how all the features of the AppFabric caching can help you do that. So the first thing is, what is it, right? All it is, it's an explicit, distributed in-memory application cache for all your data. And every word has a meaning. It's explicit, meaning you decide what goes in and what goes out of the cache. It's a distributed cache, meaning the cache is spread out across machines. So in this example, I have 5 machines here. So if you install the cache in each one of them, say each one has 2 gigs of memory, you effectively have 10 gigs of memory to cache. It's an in-memory cache. There is no backing to disk, so it's all just spread across in-memory in the servers. And finally, you can pretty much cache all types of data, whether it's CLR, XML, whatever. Anything that can be serialized or anything that's a byte array can be cached in there. So where does it fit in that grocery cart application? We said typically it's a two-tier model. So it basically slides in between your web tier and your database tier. So essentially, it's a cache tier in itself. And then you add the cache client code into your ASP.NET app. So we will see some demos on how this actually works. So then the next question you're going to ask me is, OK, yeah, I made all this pitch, but in reality, is it true? Why would I really need it? What are the main points, or why would I need it? First, you can share data amongst applications. Remember I said, if you put all your session data or other data in your local caches in your application, the problem is it cannot be shared by the other guys, right? So if you have sticky routing, there's a problem if that machine crashes. But if you put all the data in this distributed cache, any of your front-end machines, any of your ASP.NET machine can see all your data, so you don't need sticky routing anymore. Second is performance. It gives fairly good performance. If you see the throughput of it, for reads, like 2K reads, we can get anywhere like 28,000 operations a second with about 1 to 2 millisecond latency going across the network. This is across machines. And writes are about 20K per second. Now, maybe you like the number, you don't like the number. If you don't like the number, it's very easy. You just add more machines to it. So it's literally linear scale. We have seen linear scale we have tried up to 10 or 20 servers. It's literally linear scale because it's a partition cache. So as long as we know where the data goes, it's very easy, right? It just scales up. Finally, HA. So if you actually put some sensitive information in your cache, I told you it's all in memory, right? So if the machine crashes, process crashes, it's going to go away. But we also provide a feature so that we can keep multiple copies around so you don't lose that data. Fifth point, it's actually live in production. A lot of customers are actually depending on it. Associated Press, for example, is running all their custom news live on CDP 3 bits themselves. They get about 16 million hits on this cache servers. They, for example, saw that they were initially used to use just the local cache. But the problem was the local cache, each local cache couldn't cache enough data, right, for all their news and images and all the content that they serve. By going to this cache server, they were able to increase the amount of caching memory to like 6 times, and the performance also improved a lot. So they are already live, so if you go to any of the AP news content that's getting pulled out of AP, it actually hits the cache. Dell.com is also using caching. They're using it actually for some of their internal channel partner portal initially, and they're going to roll it out to their entire sales platform in the coming years. And these are just 2 of the examples. I just wanted to illustrate 2 of the companies to show that it's not just some toy technology, it's actually real in production. And a lot of Microsoft internal properties are also using it, including all the forums that you see. All the forum threads are all running on Velocity today. And of course, the final thing, remember that guy I showed you was a stingy guy, right? So you can do this all at low cost. You don't need specialized hardware. You don't need specialized network cards, none of that stuff. Plain old machines with just a regular network card should do. And it also is going to ship as part of the Windows Server AppFabric. That's why we're calling it AppFabric caching. So if you look at it, it will be part of your Windows Server. You just go enable a role, and it'll be there for you. So what stage is it in, right? So I've given you all this pitch, the nice pitch. So when can you guys get it? We used to call it Velocity before. We had shipped CDP 1, 2, and 3. Obviously, beta 1 of the AppFabric is available today. So that includes this is our CDP 4 in effect. We will have the RTM, obviously, when the whole AppFabric is RTMing next year. And also, we will have an Azure CDP also next year. I'll show some demos during the talk to see how the Azure thing would work as well. All right, so now we have the pitch of, OK, why AppFabric caching? How is it going to be useful for you? So let's actually now dive into some of the coding details and how easy it is to actually set up and use. And also, we'll dive into some of the internal features, what makes sense if your specific application needs a specific caching technology, which one should you use, and so on, which features should you use, and so on. If you take deployment, all you have to do is basically go choose a bunch of machines that you want to use for your cache, and you go enable the caching role on each of the machines. And when you enable the role, we ask you a configuration store that can store this sort of configuration information about this cache cluster. And that can either be a SQL Server, or it can be a network share, or it can be your own custom provider as well. So once we have that information, you install on all the boxes. The machines then talk to each other and form this cluster. And then you go into your ASP.NET app. You then also enable the client role on those boxes. And so the DLs will be gacked. And then you can just compile against them, and you can access the cache. And on the client side, all you would need is, in some sense, a link to one of the machines in the cluster. So we just need one machine to connect to the cluster, and then we will know the entire cluster automatically. So let me quickly switch to my laptop here and show you how that simple thing works. All right. So I have here a very simple application, really dumb application, but I just wanted to illustrate what it was all about, right? So I've just created a simple ASP.NET page with like 2 boxes, input boxes, a key and a value, and like 3 operations like put, get, and remove. That's all. And also, I have actually installed beta 1 in my machine. All this is, like I said, if you download this beta 1 bits, you can just open it, and you can install it. It'll basically ask you for adding a feature. I've already installed the cache, so it's showing us in gray. But essentially, you just go through this process. It'll ask you saying, do you want a network share, or can you give me a network share, or a SQL Server for configuration? You give that, and you're good to go. Now, one thing we also give you is a PowerShell way of managing the whole cache cluster. So if you open up PowerShell on any of the boxes, you can actually go there and look at the entire cache cluster. For example, in this case, I said get cache host. Right now, I only installed one instance, obviously, on my laptop. So it's only showing this. But if you had 10 machines or 100 machines, you can see the machine list right here. And there's a lot of cache commands that you can see. If I do a get cache help, you see all these cache commands right there, which you can use it to start this cluster, stop the cluster, get cache statistics, and so on and so forth. All right, so let's jump into the program itself. Like I said, I just have the simple ASP.NET. And if I go to my ASP.NET ASPX, the first thing I'm doing is trying to initialize the cache factory. So for that, what I'm doing is I'm just getting one of the host port and cache host name. And then I'm creating a data cache server endpoint. And then I'm saying new data cache factory. Now, you can simplify all this and add all this in the configuration file, but in this case, I've just like explicitly listed them. So I've said, OK, connect to Mercurius2 and this particular port. And that's pretty much it. So this is creating a cache factory, and then from a factory, we then say, get me a cache. So that get cache call that you see here is called a named cache. So I'm saying, get me this cache called catalog. Now, you can create actually multiple named caches. So if you go here, I can just give this command called new cache and just create any kind of cache. The idea of a named cache is that you can put policies on the named cache. For example, if catalog is storing reference information, like your catalog, you may not care for HA. It's OK, because you have the data in SQL Server. You can fetch it, right? Or you can have different eviction policies. Or for example, if you have inventory stored in a named cache called inventory, you might want you might want high availability for it. You may want to have no eviction turned on. All that kind of policies are specified at that named cache level. So here, what I did, I'm just saying, get me this data cache, go to the cache factory, get me a cache called catalog. So once I have that handled, I can do all the operations on it. And the API on the cache is extremely brain-dead simple. It's just get, put, and remove. That's all you need to know about the cache. And you don't need to know if it's 1 machine, 10 machine, or 100 machines. It's the same single API, set of APIs. So if I go to my button here, I can go to ASP.X. So I can click on put. So if it's put, what do I want to do? I want to call cache.put, right? And my thing is called keybox and value box. So I'm just getting the values from there. And then I'm just going to say result box.text equals success. So that's for my put. For my remove, all I'm going to do is cache.remove keybox.text. And it's a little hard typing with this keyboard here. And the get, actually, I've, I guess, already populated it. All I'm doing is doing a get of it, and then I'm setting the result to the result box. So let's run this guy and see what happens. So first run this guy. This code runs fine on CDP3, but you see it's taking a little longer. This is on beta 1. And if you just give it a second, you'll see what happens. It's going to come back with an error. It may be news to some of you who are already using CDP3. It's this simple. Why is it giving an error? You'll see why it is so. Yes. And you see this big, gigantic error string here. We're going to clean this up. But essentially, all this is saying is, oh, there's a temporary failure. Go check something. And that check something is your security. So in beta 1, the cache is secure by default. Only authorized client can actually connect to the cache. In CDP3 and before, we didn't have security. So anybody could connect to the cache. But starting from beta 1 onwards, by default, it is secure. So I first go here, and there's a command called, you see this command here, right here, called grant, revoke, and get. So I need to add myself as an authorized client. So I say grant cache allowed client account. So added myself as an authorized. So you can add either machine accounts like network service, or you can add any particular user as well as a client. Only those users would be allowed to connect to the cache. So if I go back here, let me stop this and restart this guy again. And you see it now works. And I can put some values here. I just did a put, and I can do a get. I can do a remove. You see how simple it is, right? And like I said before, the APIs don't care for how many machines you are, and I could have 100,000 clients accessing this cache, and everything would work the same. So it's extremely simple to set up, extremely simple to use, and in beta, we also have the whole security feature as well added. Right, let's get back to our PowerPoint. One thing to also add, obviously, security does add overhead. So if you already have other security that you can use, you can turn it off explicitly. And you can turn off security altogether, or you can have higher levels of protection as well in your security. And like I said, admin and monitoring, we do use PowerShell. We also have perfmon counters enabled. We have about, 40 or 50 perfmon counters that you can look at as well in the cache. That's new in beta. I'm going to skip this. One other feature that we have in the APIs is something called regions. I just showed you a simple get and put. If you want to kind of put a bunch of objects together, you can actually create what is called a region and throw the objects in that region. That gives you the ability to kind of treat them as a group for either fetching or for deleting. Classic example, MSDN or MSN uses them for sessions. So if I log in, they create a session for you, and they actually create a region, throw all your properties in that, and when you log off, they just delete the whole region in one shot. So that's a very simple example. And this is the overall logical hierarchy. You have all the cache servers, and you have all these named caches that are kind of spread across them with different policies, like I said before. And within each named cache, then you have all these keys, values, and regions. One other small API that we also have, in addition, is called tagging. In addition to just a simple get put, you can also have secondary indices. So you can attach tags to those values, and you can actually have an index on it, and then you can look up by the tags. So I can, for example, add to my toys, I can add saying it's a hot item or a discounted item, and then I can fetch by that particular tag. So you can query on the tags. And often an ask from CDP3 and beyond is, hey, can I query on all my regions, all the system-created regions? And we are enabling that in beta. So you can actually go query all your default regions as well. And one thing I want to remind is it's an explicit cache, meaning the way you pattern to this cache, you first try to get from the cache. If the object is not there in the cache, you then go back to some database or data source or wherever it is, grab the object, and throw into the cache. And it's sort of your application that determines what goes in and what goes out of the cache. OK, so we saw some of the APIs of the cache, and that's pretty much all you need to know how to use the cache. Now let's get into sort of the internal details of how it actually works and why it works the way it works. So first thing is, how does it scale? Like I said before, it's a partition cache. So if you have different clients throwing in different objects into the cache, they all get distributed into kind of the cache cluster. And we use some partitioning logic. We use the keys. We hash them into partition buckets. And then these buckets are called partitions, which then map into nodes and so on. So there is a pretty sophisticated logic that's going on in the clustering layer itself to figure out which objects go where. And because of this, as you add more machines, you can actually add machines dynamically to this thing. And we can repartition the data seamlessly without actually losing any connectivity from the client. And you can scale your servers pretty dynamically. And I used to show the demo before, but since we only have an hour left, 45 minutes left, I'm just showing the graph. You can go back and actually look at the videos if you go to msdn.com/velocity. Essentially, if I add the green graph that you see here, basically that's the throughput. Red is the load, and blue is the response time. What I had done here in this specific test is I had one server to start off with. I had increased that red graph that you see, and that server's network gets saturated. So you see the throughput kind of flattening out, the response time going up. And then right at this intersection, right at this point, I added actually a new server dynamically. There was no loss of kind of connectivity from the client. The client's throughput just jumped, doubled literally, and the response time halved. Again, I can add another server, and the response time again would go down, and throughput would again go up, and so on. And there's also recently, Grid Dynamics actually ran some benchmarks on our thing. They published numbers. They took actually different use cases and loads, like Blog Engine, which is primarily read intensive, then like a session kind of data, which was like read-write intensive, and something on notifications as well. They did run a lot of numbers, and it's very good results. You can go in detail. It's a huge kind of a document that they've written. Again, you can get it from the blog site. And if you look at it, the throughput curve is like a nice linear curve. And as you see also in the bottom, if you add nodes to the curve also, you see a nice linear pattern. The yellow or the orange one is the one that doesn't use velocity. It's like using a database or something that doesn't like linearly scale. And you can see the difference. There's pretty significant differences in these things. All right, so now I'm going to jump, now that you know it scales, I'm going to jump to some of the features in the cache and what features make sense for your application to use. Yes?
How does it scale across like buildings, locations, if you're not running it in the same data center?
Yeah, so the cache right now is kind of, we prefer that it be within a data center. And then you have separate cache clusters across data centers, because obviously the latency between the data centers is variable. And so our lease timeouts and all that become a problem. If you have, I can talk about this later. Once I get to the talk, we can talk in detail. First thing also to note, as I talk about the features, you should use the right features. It depends on what caching data that you have. And you can have, usually what we've seen in all the customers that we have seen is like three kinds of data, right? It's either reference, activity, or resource. Reference is primarily read-only data. Activity is read-write, but not shared. And resource is read-write and shared data. And you have to also look at, once you identify what kind of data it is, Is it what's the performance characteristics that are needed? And what is the throughput needed? What is the latency needed? And the second thing you need to look at, what is the consistency that you're willing to give up? Is it OK if it's stale for a few minutes? Because if you can give up some consistency, you can get higher performance. So that's the second thing you need to look at. You need to look at, is it evictable? Is it some data that it's OK if, for example, you put a lot of data into the cache and the cache cannot handle the amount of memory is not enough, can I throw some item out of the cache? And security, if you're bringing it from very secure sources, remember you are getting into the cache, and the cache has a different security model. So is that OK or not? Or do you need to encrypt the data before you throw it into the cache? That's something you need to think about. And finally, should the cache itself survive node failures? Do you need to turn HA on in the cache? Or do you need to have like separate clusters to do kind of cluster level survivability, availability or not? So if you take that grocery shopping cart, like I said, the reference data is all that catalog information that you see in that cart. Right? All that catalog that you see in a typical grocery cart, grocery application is your reference data. And that's primarily read-only. It can be gotten from a database, so it's OK if it goes out of the cache. The other part, when you actually go around shopping for your grocery items and you're adding them to the cart, that's your shopping data, right? And that's not shared. Basically, each one has its own shopping cart. And typically, you don't want to lose that shopping cart, so you do want to turn on something like HA on, high availability on. And the final thing is like the inventory. If you had actually grocery inventories, like what's the number of items left in my shop? So that's an inventory data, and that's going to be shared across all these users, right? It's read, write, and shared. And so you may need locking semantics on it. So let's quickly see what the features that are relevant for these kind of data. So the first kind of data, reference data, is first thing you're going to be asking is performance, because the number of people who are going to go through, browse through your website looking for all the catalogs is going to be a lot. Right? The number of people who are actually buying is probably small. The number of shopping carts is going to be small, but the number of people browsing the site is large. So performance becomes a key thing. And here's where you need to figure out, hey, can I tolerate some level of inconsistency? In the sense, if somebody is looking at the catalog, how frequently do you update the catalog? Maybe once a day, once a month? That's something you need to figure out. So we have a feature called local cache that can actually help accelerate performance. Typically, in the regular cache setting, anytime you do a get or a put, we are going across the network to wherever that data is and fetching that data. But when you turn on local cache, what happens is the first time, we would have to obviously fetch it from the backend. But subsequent gets can be short-circuited right there. So this can give an order of magnitude performance, like 200 or 300,000 operations per second. And obviously, the problem here is that some other application could come and basically change that data. So then you may have some staleness. So this is where I said you need to look at the consistency issue, right? Are you willing to tolerate staleness? And so what we allow you to do is to say, on the local cache, you can either set an expiration timer to say any object that comes into the local cache, I know I can tolerate a minute of staleness. It's OK if my users see a minute of staleness, so I'll set an expiration to be a minute. And so you will always be assured that the data is fresh as of a minute. The other option you have is notifications. You can turn on to say, anytime something changes, frequently go scan the cache servers to see if things have changed that are present in my local cache and update them. That, again, is a poll-based timer you can set saying every 5 seconds or every minute. And that will only update the objects that have actually changed. The other features that we are adding in beta, which is not there in CDP 3, is bulk get. So you can actually, if you know you're going to fetch a bunch of items together, you can actually send all the keys to us and say, OK, fetch all these items in bulk. And again, likewise, because this is amortizing the whole network cost, it's going to give 200 or 300,000 operations a second. It's pretty efficient. Next thing is activity data. And one of the key things in activity data, like I said, is session cards. Right? People use session cards a lot. And primarily, a lot of people, ASP.NET users, use the ASP.NET session as a means of storing their session information. So what we have done is a very simple integration to ASP.NET, because ASP.NET makes it a provider model for the session store. So you can actually just drop in a configuration into the ASP.NET web.config that says use Velocity as a session cache provider. And the moment you do that, you basically all your sessions are going to get stored in the Velocity cache servers. So you can both scale all your session data beautifully, because if you have a lot of sessions coming in, you can just add more servers. Also, you can make it highly available. So if you used either local session state provider or out-of-proc session provider, you know the problem, right? If that machine dies, you're losing all your session data. But here, because that session is actually distributed across machines and copied over, you are protected from machine failures. And of course, you don't need sticky routing anymore, because all the data is actually sitting in the cache servers. And another thing in beta, we've heard your feedback. We've also added session state to be actually shared amongst applications. So if you have several applications that are using the same session data from the user, you can actually share it as well. That's fairly easy to set up. And another thing, obviously, like I keep talking about availability. So what exactly happens in high availability? So when you actually try to put an object, typically, if you don't have high availability, it just goes to this cache 2, wherever it needs to go, and then basically returns back. Now, if you turn on HA, which is exactly a single setup that you have to do when you create a new cache, you just say, create me this name cache. Please turn on high availability for me. That's all you need to do, nothing more. And what happens is, instead of just storing it in one machine, we actually store it in another machine as well. And this is, again, distributed through the system. So it's not like one machine is the primary, another is like backup. That's not the case. If you have 3 machines, the data is actually spread across all the machines, and the backups are also spread across all the machines. And they spread across such a way that one machine going down does not bring down both your backup and your primary, right? So we make sure the primary and backups are kind of like spread across. And so in this example, if cache 2 were to just die, then what will happen is we have actually a fabric layer and a clustering and availability substrate which detects the fact that cache 2 died, and then it tries to then figure out, OK, who is the backup for that particular data or partition. It'll then tell cache 1 saying, hey, you are now in charge of that particular piece of data. You are like the primary for that data. And then it'll ask cache 1 to say, OK, now go create yourself another backup for you. So all this happens in basically a few seconds, and it depends really among the amount of data that needs to be moved around. But pretty much the figuring out of the fact that a machine died or a process died and setting all these things up just takes a few seconds. And in the meantime, the clients might see a delayed response to those affected partitions only. So if, for example, my second application is actually performing a get to this, to say cache 3 or another machines, it won't have any problems because it is able to access them. Only if it tries to access this machine which has gone down, then it may experience some delay, a little bit of delay before it figures out, oh, the cache 1 is now the new primary. I need to go talk to it. Third thing, so we talked about reference data, how you can improve your performance. We talked about kind of activity data, how HA and some of these features help you. And the third kind of data, like I said, is resource data. And to kind of recapture resource data is data that's read and write and shared, like your bitcode auction or your inventory and so on. And obviously, in anything that is read and write shared, you want locking. And we actually provide you 2 types of locking in the cache, optimistic as well as a pessimistic locking mechanism. Optimistic locking, like the name suggests, is basically we don't take locks, right? So what you do is, in your application, when you actually read an object from the cache, you actually ask the cache to say, get me a version that I read the object with. And then you do some updates with that object. You then send back the updated object, and you say, here's the version that I read with. If the version on your backend matches, perform the operation, otherwise reject it. So let me give you an example. So I have 2 processes. They're both trying to get the cache item, the Zune inventory. So they're trying to get the Zune object. They're both updating the inventory. They're subtracting the inventory. And the first guy gets in first with their put operation. So it's going to succeed because the version that it has is the same as the backend. Now, when the second guy tries to perform the same operation, that will fail because the thread 2 had actually gotten in, changed the version of the object, so the first one would fail. So in this situation, the application would then just have to retry that operation again. Of course, if you're more comfortable with the pessimistic locking mechanism, you can do that as well. There is a get and lock API. So you go fetch, give a key and say, hey, take me a lock on this object. And obviously, you have to give a timeout. Because it's a distributed cache, your clients may die anytime. So any get and lock mechanism, you'll give a timeout. And so we will honor that lock for that timeout. So any other object that's trying to get a lock will fail. And regular gets will always work. In our system, reads don't take any locks. Throughout that kind of the entire hash table, reads don't take any locks. Writes are the only ones that take latches at the lowermost level. So in this scenario, only if you perform another get and lock, it will kind of say you don't have the lock, but gets will continue to work. One new thing that we've done in beta, this is again a lot of requests that we had, is to allow a lock on a non-existent key. So if I say get and lock, before you had to have that object present in the cache for you to be able to take a lock. Now we allow you to take a lock on just the key without the value. The question is, you may ask, why is that relevant? It's very useful when you're actually writing an app and you want to say, load up a page. Like, for example, it's an expensive page. And you don't want every single of your front end actually hitting and finding out, oh, this object is not loaded. Let me go grab it from the back end and load the object, right? So you can actually just figure out, oh, the object is not there. Let me take a lock on the key, and then let me go populate the object, and then the rest of the other guys don't have to do the same. Yes? But because it will see the snapshot, right? If there was a previous value for that key. So the question was, how will the regular get succeed when I'm doing a get and lock? That obviously works if you had some previous value. Like let's say I had key K1 with a value V1, and I now do a get and lock on K1. So no one else can do a get and lock on it. But if I do a get of K1, I'll still get V1.
Yeah, but if now you do an update, regular update without lock,
Yeah.
then get and lock will fail.
Yes, what happens is the question again is what happens if you do a regular lock? If you actually do a regular put on the object, we will actually break the locks. So you need to be careful using the get and lock and the put and unlock. You need to use them in tandem. So there is an API called put and unlock. So that will only work if you were the one holding the lock. So if you do a get and lock, you should call a put and unlock. You should not mix the lock and the lockless APIs. There is no deadlock in the system, right? Because the deadlocks usually occur if you have sort of transactional behavior. There are two ways, right? If your application is actually, locking different keys, there is always timeout here. Every lock has a timeout. So some of the locks would time out after a period in time. So when we support transactions, yes, we would obviously have to look at deadlocks as well. Final thing, kind of the final feature that is relevant for the resource activity data is notifications. The cache actually supports notifications, which means you can actually track changes that are happening to the cache at the level of a key or at the level of the entire cache. So it's very simple. You go to your application, all you say is register a callback. Here's the callback that you need to call, and here's either the name cache. So if you want to see any changes that happen, say at the catalog level, or at the region level, or at the key level, saying if K1 changes, let me know. And obviously, any of your application can register for it, and if something changes, the cache will call your callback and say, hey, this is the activity that happened, and this is the change that happened. And the way, and obviously in beta, we've also added a bulk notification feature as well, so you can actually get the changes in bulk. And this was primarily added because Xbox Live was trying to use the system, and they needed something like 1.5 million notifications per second. Because they were trying to track every single login, log out, and all that. And the batch notifications obviously helped a lot because their notifications were like 30 bytes. So every network call, we were doing individual things that obviously wasn't helping. By batching them, it was pretty efficient. That was the main reason we actually added the bulk notification. You had a question, yes?
So when you get if you're using local cache on your front-end boxes, you could register notifications that your cache data was actually stale, and then you could react.
Exactly. So this is the same thing we use for the local cache. So in the local cache, you can actually turn on, like I said before, you can say, sync my local cache with the cache servers using notification. You don't have to do any coding. What we do is internally, we actually, as you enter data into the local cache, we will actually create these callbacks automatically, track the changes, and then invalidate the items in the local cache. And so the way it works, if you're interested, is very simple. So if you register for a key called K3, we figure out which partition or which bucket it maps to, and then we will poll that server, that specific server, saying, has anything changed in this specific partition? Now, the servers maintain a log, like if you think about SQL Server or any server. We just maintain a quick in-memory log that says, these are all the changes that have happened with this number. There's a sequence number for all the changes. And so the cache 3 initially would just send in saying, OK, my sequence number for this particular bucket or partition was 19, was my last. So the client actually tracks that number. And so subsequent, so you can set a polling interval. So every 5 seconds or every 10 seconds, it can go poll the server and say, I last saw 19, change number 19. Do you have any more changes? So this is a simple way how this thing works. So it's internally a kind of a polling mechanism. But from your application, it looks like a push. But this scales beautifully. Like I said, for the scale that Xbox or other thing wants, this actually scales very nicely. The servers don't keep any client state, if you will.
Do you get back the tags on the item when it's been expired or whatever?
Actually, no. That has been a request. So the question is, do you get the tags back on the item when it expired? Right now, the notifications only tell you this key has changed or what has happened to it. We don't send the value back. And that's something we have had an ask for. Don't know when we'll get to it, but we're looking into it. Because obviously, if you had a deleted item, you don't get the value back. You got to go back to the cache and ask for that key, right? So, OK, so we talked enough. So let's go into some demos. I'm going to go to my G box. So I have here actually running on Hyper-V. This is a pretty good box that they give us. So it's running actually 3 VMs. There's VM 1, 2, and 3. I'm calling it Northwind 1, 2, and 3. And let me first go to the PowerShell. Like I promised before, you can go do a get cache host. And you can actually see all the 3 machines right there. Okay. Can you guys see? All of you guys see? OK. So what am I going to do? This is the grocery shopping cart. So let me bring up VS. It's a very simple application. So I have here all the ASP.NET pages, like you would imagine in a grocery website. And there's a business logic. All that is doing is actually implementing like the categories and other kind of APIs that the pages would use. And all it's doing is if there is a use cache, then it will call the cache. Otherwise, it will call the data provider. And the cache itself is implemented, obviously, using Velocity. And what it's doing is it's calling, again, the factory.getCache of catalog and reports. There are 3 name caches that I've created, catalog and reports, and then a session name cache for storing all the session cards. And so if you go inside my product, my purchase order, there's an add to cart button. So if you look at the add to cart, let me zoom here. So look at the add to cart button. This is just using a simple ASP.NET session. We're not doing any magic here. So it's just saying go to the session. If the thing is not there in the session, just add my item to that session. And so if I come back here, what I've done is in my web.config, I've added this single line that says, sorry, I have to keep doing this to get my Zoom it to work. So all I've added is 4 lines of code that says use Velocity as a session store provider. So all the session data that I'm dumping into ASP.NET will get into Velocity. All right, let's see this in action. So let me minimize this guy. I'm going to open up AFC Northwind first. Ask me later. So you see first, the page came up, and there are a bunch of things in red. And what I have done is I've just colorized it to say if it comes out of the database, make it red. If it comes out of the cache, make it blue. So you can visually see the difference. And so if I'm going to refresh the page, you would see it all turns blue. You see that? And obviously, it's like a millisecond. It's coming all from the local cache. Let me now open up. I've installed this thing on all 3 machines. So I'm going to open up the second box. It's going to go to AFC Northwind 2 here. ASP.NET is just booting up, and it's going to come up. And one thing you should notice when it comes back. Yeah, you see that first time it didn't come in red, right? It came in blue because the second ASP.NET application did not have to populate the cache. The first one had already populated. So for reference data like catalog, also, it's very useful to have the cache because you don't have every one of your front-end boxes trying to populate the cache. So let me do something here. I'm just going to go ahead and purchase a few items. I'm just adding to the cart. So I'm viewing the cart here. I have 2 items in the cart. So if I go to my first machine here, I do a view cart. Obviously, this cart is empty because the session ID here is different from this session. These are 2 different sessions, right? And if I were using local session provider in ASP.NET, that's a behavior you get, right? Whichever ASP.NET machine you get, that's a session you have. But because I'm storing the session in Velocity, I can actually spoof it. I can actually I'm going to cut and paste that session identifier from my second box and paste it here. And let me get the URL right. Oops. Wait, let me get the whole URL right. And you see, I went to Northwind 1. For you who can't see the back, I went to Northwind 1. I just cut and paste that session identifier from my second one. I can see it, right? So this means I don't need sticky routing anymore. I can go to any of my boxes. So I don't need my load balance to be sticky routing. So I can scale my front-end tiers very well by offloading my session to the cache. Now, the next question is, OK, so what happens? So let's do some. So I'm doing a get cache region call. the get cache region shows me the data distribution of the things across the machines. So in this scenario, let me make this slightly bigger so I can zoom it here. So you see that Win 1, 2, and 3, the sessions are kind of distributed amongst the machines, right? So you see, for example, North Wind 1 is primary for one region, 802, and the secondary for that is in North Wind 3. And similarly, North Wind 1 is secondary for 67, and Wind 2 is the primary for 567. So you see that primary and secondaries are distributed. So let's do something. I'm going to go kill the VM, one of the VMs. Which one do we want to kill, 2 or 3? 2. All right. So I'm just going to turn off 2, right? So the machine just blew up. So let's do a get cache host. Now, one interesting thing you should notice that there is a difference between the process dying and the machine dying in the way how TCP/IP behaves. If a process dies on a box, you can instantly find out that the process is dead because the port is off. Whereas if a machine is turned off, it takes a few seconds because we have to wait for the TCP/IP to time out that the machine is actually dead. So there is a difference. There will be a difference in the failover, a machine dying versus the process dying. So this is going to take probably a few seconds or so. So it's saying, yeah, I cannot actually access machine 2 because it's trying to go access that machine 2. But what I'm going to show you, get cache region, and I'm going to do session. So if it comes back in a second or two. So you see what happened here. This guy, the North Wind 1 and 3 are the only ones remaining. This actually picked up the secondary, and if you give it a second or two, it'll actually move the primary over to North Wind 3. So you should see it'll basically get redistributed. The partitions would get redistributed. The regions would get created. And if I actually go back to my thing here, yeah, you saw it. Let's see what happens if it's still up and running. It's taking a little longer. It should have automatically created the primary for that other secondary. It's always with the demo, right? It all works. This guy is down. OK, so it'll come up. I'll give it a few seconds. It'll come up. So trust me, it works. And like I said, if you don't believe it works, you can go to all the videos I've done before. And yes, it has worked before. So yep, oops. Maybe it hadn't created the primary for some reason. OK, I'm going to proceed with the presentation. We'll come back to it. I'll show you the fact that it actually works. So. OK, so that's kind of like some of the on-premises story. And the other thing that we're also working on is kind of the Azure caching story. Let's say you become a popular grocer, right? And a lot of people are coming to you, and you have inelastic demand, and you don't want to acquire like a lot of hardware, software. So you have a bunch of solutions as well, right? In addition to buying, like, actually using kind of the local caching story, you may want to scale up your backend tier, like data tier. So you could move sort of the data to SQL Azure. That's one example that you have. Or you could move your entire application to Windows Azure and SQL Azure. Or you may just move the front end, like the Windows Azure portion alone, and then keep your data in the backend and communicate through Service Bus. So you have all these options. And the Velocity or AppFabric caching can actually help you in all these three situations. So if you have a situation like this where only your data is in SQL Azure, obviously this is going to take you 1,000 milliseconds or so, or 700 milliseconds to actually get data from the database. It's going across the network, right, to grab data. Clearly, caching is a big winner here. There's no doubt, right? Second scenario is where you have the entire application running on Windows Azure. This is another frequent question I ask. Say, hey, Windows Azure already provides me the scale. Why would I need caching? Here, the cache's role is not the scale, but more of performance. Even if you're putting all your app online, there is still that same latency involved like the on-premise solution. You have a data tier that is separate from your box. You have your app tier. Your caches are going to run closer to your application tier, so you get all the benefits as the on-premise solution. And the final case is where you have sort of the app alone running on Azure, whereas your database is local on-premise connecting through Service Bus. Clearly, it's again brain dead that you do need a cache there. It's going to take you several orders of magnitude performance difference. So let me switch back to the thing, if it ever came back. So what I'm going to show you is actually a simple change in my. So what you can do is SQL, if you want to go to SQL Azure, all you have to do is just change the connect string, right, my application. So SQL Azure gives you that ability. So I can just say Northwind on SQL Azure, and all I'm going to do is just start connecting to SQL Azure, and my cache actually works the same. See, it actually created the primary here. Yay. So now this should come back, hopefully. I have to show you guys that the cache is not lost. Another interesting thing, actually, I've tried killing all the machines all the way up to one machine and then adding them back. That works as well. Another interesting thing there is one thing you need to realize, when machines go down and the primaries are reorganized, the key thing, I still get the error, or is it still running? Oh. OK, I'm going to ditch this thing. OK, see, another key thing that you also have to recognize that is when a machine goes down and the partitions are reorganized, read access are almost instantaneous once the partition moves around. Now, if you have HA on and then the writes are happening, what happens is if you've set the min-write quorum to 2, the writes cannot be handled until the secondary backup is also created, which is why we were seeing these errors. Right? It was waiting for that backup writes to be created. Otherwise, this other copy was already available, but it wasn't allowing us. There is a simple configuration tweak that you can do to say, I don't want that. I actually want you to allow writes the moment you at least have one copy around. And that will actually prevent these kind of errors. So you have your almost instantaneous failover as opposed to waiting for that secondary get rebuilt. OK, so what I'm going to so if you just change this string to Northwind SQL Azure, we'll actually have I'm going to just cut this out here. I'm going to go back to my original thing. Yeah. So what I've done is I've just changed this to SQL Azure, and I'm just going to go up to my app, and I'm going to refresh the app. You see here the app is all in the cache. Now, obviously, it's taking about a millisecond. Let me turn off the cache to actually show you that it's actually going to SQL Azure. And that you will know immediately. So you see here, this is actually going across the network or across the web. And you see it. You see the order of magnitude difference, right? So if I refresh, this cache off button says that always go to the backend database, whatever the database is. In this scenario, it's obviously going across the network to some backend store. And obviously, that's taking time. So all this simply illustrates is clearly a caching is a winner in this scenario as well, right? If you have your data stored on the web, and if you have your application on premises. And the next thing I want to show you is what if your entire stuff is online. So what I have here, let me switch to my laptop if I find out where that is. See. So I also have actually a prototype working where we have the entire cache running on Azure. So if you looked at my original Northwind demo, all we had in the client section was something like, OK, what's the velocity host port, et cetera. Now, in the cloud case, I have actually a cloud service called Cloud Service 2, which has the roles created. The Northwind cache demo itself is a web role in this scenario. And I've created actually the velocity cache as a worker role. So it's actually going to get kind of uploaded as a worker role. And here, all I have to change is the section that says, section here. Oh, this is the cluster config. Let me go to the web.config. All I had to say was use this Azure role and say, OK, my Azure role is called Azure Cache Worker, and use that. So if you look at actually the velocity code change, it is just a single line change, or rather 2-line changes that says, OK, use this data cache server endpoint by using the Azure APIs. Unfortunately, it's too big to show here. The Azure API, you can give a role to Azure and say, what is actual IP endpoint for these worker roles, right, of the cache. You have to just call that API and then feed it to us into our data cache factory, and you're done. The rest of the code doesn't have to change one bit. And I have deployed that app onto Velocity, and you see this is where it's running. So you see like my Azure Cache Worker, there are 3 of them, and then like 2 of the web things. Yeah, and I can actually go there. It works. and basically, you can go there, and it's the same cache, right? So all the stuff works. I mean, whether it's HA or it's the performance, all that kind of stuff. And when it comes up, when Azure rolls, I'll wake up and give me back the data. You will see it's coming back up. Initially, it's a little bit, and you see if you see the time, it's like 15 to 0. It always fluctuates between the two. And obviously, all the data is, again, on SQL Azure. So here, you would see, again, the difference. Everything is running on Azure. So if you do turn off the cache, you still have a difference. So even though everything runs on the cloud, there is a difference, right? So caching is very relevant here. And I haven't done the service bus example, but you can imagine, right? If I put my web app and Velocity on premises and have the database local, clearly, again, the cache will win. So I guess the point I was trying to bring about is there is a service plus, there is a software plus services symmetry here. You can run cache on premises. And Azure, we are working to get a CDP out next year, so where it'll be very simple to kind of use it on Azure, but the rest of your code doesn't have to change your cached output or any of them. It may just be a small config change that you say, instead of Data Cache Factory, it could be Azure Data Cache Factory, and you give the worker role name. That's pretty much what it'll be. And your cache will help you whether you're on-premise or in the cloud, in all possible combinations. So I have 10 more minutes left, so I'll quickly wrap it up and open it for questions. Another thing we are working on with ASP.NET, obviously, you may have gone to the talk that Stefan gave. ASP.NET in 4.0 has opened up 3 of their APIs. Their cache surface itself, they have this system runtime caching. All that is, it's an interface, so we worked with them to come up with an interface that can be kind of shared both by the in-memory ASP.NET cache as well as Velocity and other, obviously, third-party providers. So we will try to become one of the providers there. Another big ask from the ASP.NET team is to have Velocity as an output cache as well. So today, ASP.NET outputs the like dynamic pages or static pages into the local cache. But if you can throw it into Velocity, then you can share it across all the machines, and you get a much, much bigger memory to cache all your output pages. That's something we may get it out sooner. Granular session updates is another thing where instead of if you modify a session object, that entire glomp of session objects is actually sent across and back. And what we worked with them to come up with this granular update, so if you're modifying a small portion and your session object is large, you don't have to send back all the changes. And the way we are thinking about it is to kind of map it to a region so that if you make small changes, only the keys in the regions are affected, not the whole session object. Cache through is something we hear frequently. Unfortunately, it doesn't look like it'll make the V1 cut, but we're looking to see how to get this in. But what this will provide you when we get it is to make the cache more not explicit, but more implicit, where you can actually have these callbacks plugged into the server side. So if you have a read miss, it will call the callback to load it. Or if you write to the cache, it will write it to the backend store. Bulk access APIs to make it also for put also is something we're looking at. Another thing we're working with the HPC team separately as part of the HPC charter is today you can use Velocity in HPC scenarios if you have a high performance computing. Again, Grid Dynamics did a block. This actually was in CDP1. They did it last year or early this year. And they saw like 50 times improvement in a lot of scenarios. And so you can just throw Velocity today into HPC. What we're working with them is to make like a cache role. HPC has a notion of roles. So to kind of integrate into their thing and make like a cache role so that you can easily install and configure Velocity on HPC clusters. That's something we're working with them. So in concluding, basically the vision is for us to kind of give you a cache for all the web scenarios, your IaaS, ASP.NET, so that you can have high scale availability and low latency access. In the enterprise scenario, to actually give you persistence, like read through right behind, integrate with HPC, queries, something that'll probably come in the future, and co-location of computation and data. That's part of our AppFabric vision, is to be able to, that's another thing that we're working on, obviously, with the whole AppFabric umbrella. Like we did kind of the thing for data with the cache, we want to actually integrate the computation, like services and the data cache together, so that service can run where the data is and vice versa. And finally is S+S scenarios. To show you a bunch of demos, but it'll be more reality next year where you would be able to use the cache in all kind of S+S scenarios. So that's pretty much I finished kind of 5 minutes left. And there are other labs, there are hands-on labs and other related talks as well that you can attend or see on the web. And of course, please do fill out the evaluation forms. Your feedback is important. And questions. Thank you. Questions? Yes. Any questions?
Yeah. Maybe you could answer Well, one question that comes to mind right away, is there a size limit on each item being cached? Is there some,
Okay,
what are the limits of the system?
Good question. So the question is there any size limits on the items being cached? We don't put any limits on the items being cached. And we do look at, because we don't want the items to go into the large object heap, we don't want the items to go into the large object heap. We do chunk them up into smaller byte arrays. But in reality, the cache works better if they are medium-sized objects, because if you have very large objects, the streaming, it pretty much captures your network cards, right?
Right.
So you're not able to scale the cache very well.
And so what?
So it'd be better off if you had a large object to actually you chunk it up and throw them and distribute the pieces on the cache.
Okay.
You'll get much better behavior.
Okay, thank you.
Sure.
Quick question on the
Sure.
security you did up front where you granted yourself
Yeah.
the permission to use it. Is that the name cache level? Can I put different users?
Very good question. The question was, is the security on the cache name cache level? Actually not right now. Right now it is at the server level or the cluster level. So all the accounts that you provide, everything is for the cluster, not for the name cache inside it. That is something we're looking at, but it won't make for the V1 card.
Are there any built-in components for pre-populating the cache? Like my ASP.NET clients doesn't have to wait if the cache is
Good
expired?
question. So the question was, is there a way to pre-populate? We don't provide anything out of the box, but the simplest way is to put it in your statics or to have a separate program that just loads the cache today. So we don't provide anything out of the box today.
Okay, so again, to add on to that, do you have any particular protocols like TCP or sockets to connect to, or is it specified?
No. So we do give you the clients. So the clients, you just use the client API and talk to it. The client actually uses just TCP, WCF underneath the covers. It uses NetTCP binding with XML binary encoding. That is what it uses. So we are looking going forward to actually support the OData protocol as well. But that won't make the V1 cut. But we are planning to support it in the V2 version so that you can then have any clients of your choice.
Okay, thank you.
Sure.
Hello. Is considered SQL cache dependency?
SQL cache dependency? No, that is not something that we're looking at the cache. The primary reason we didn't do it was because this is a distributed cache. If you add a SQL cache dependency on a client side, it's really hard for us to migrate that cache dependency. So what we are trying to do is we are looking for V2, we are looking to see how better to integrate with like sort of the SQL change capture and other things so that if you link your cache items to SQL, we know to go invalidate them. So we can't support SQL cache dependency by default in the cache.
Hi, I have two questions. First one is regarding, was there any study done in terms of having the session provided as SQL and then using the HTTP context?
Oh yeah, good question. So is there a study done on session provider being SQL and cache? The Grid Dynamics blogs, go read it. Actually, it has exactly that. It uses a database as a session provider versus Velocity. It showcases what's the throughput characteristics, what's the scale characteristics, and everything.
So if I use the HTTP context on the server, it would serve the session objects on the local machine. So what is the delta between using the state cache servers versus having the ASP.NET local session?
Okay, good question. The question is, what's the difference? If you're using ASP.NET local session provider, obviously that's going to be the biggest, highest performance that you can get because all your sessions are in memory. But the disadvantage is obviously you have to have sticky routing enabled, right? You can't go to any other ASP.NET session. And if this machine goes down, you're going to lose that session object, right? So that's the difference. You cannot compare the performance of that with any other system, like even going to SQL or to Velocity. Now, what we do compare favorably is to, say, the outproc. If you have the ASP.NET outproc state provider or to SQL Server, obviously we are kind of very similar. And the advantage we have, obviously, we can scale much better. So if you have, instead of 10,000, you have 50,000 objects, it's much easier to scale with us than with, say, outproc or SQL.
One feedback on caching on the servers, is it dynamically allocated? Like, I want to, if I'm just using one of the servers automatically and there's another server available but not used that much, is there a smart engine which says, you know what, I'm going to allocate now the new cache in this?
Okay, so the way it works is it's a partition cache, right? So if you have your keys, the keys are actually mapped to what are called either default regions or user-defined regions, and the regions get distributed across the machines. If I add a new machine, we actually have a load balancing algorithm that runs and says, oh, this machine is actually empty compared to these. We actually dynamically move them. The way we move them is we create idle copies first. We copy the data over. Once all the data is kind of up to date, then we switch them, saying, okay, now this machine is responsible for that region or partition.
I see.
So that's how it works.
The last question I had is regarding the data consistency. So if two web form servers updating one key, let's say my
Yeah.
item,
Yeah.
how would
Okay.
what is
so
the best practices?
by default, the question was data consistency. By default, writes are atomic. You will not get corruption. So whichever write gets first or last, rather, would win. So if suppose this ASP.NET 1 and 2 are writing the same key, whichever guy got last would obviously overwrite the previous value. You can prevent that by either explicitly using locks or by using some of the optimistic version. But otherwise, writes are atomic.
What I meant was, is there any specific namespaces that the application developer could be?
Yeah, can we maybe continue
Sure.
the conversation after this? I think so, yeah.
Is the caching technology dependent on any particular, let's say, IIS? Do we need to use
No,
it in the
no,
ASP
caching is not dependent on any of them. So this is a pure .NET cache.
Right.
So obviously, it's part of the AppFabric. So the
Right.
requirements, basic requirements are going to be WinServer 2K8 and .NET 4.0. We're going to base it on that.
So if let's say I have a data access component server
Yeah.
dedicated, and if I want to use this caching server over in the data, kind of let's say I'm going for a catalog, and I find the catalog is not there in the cache, then I get it from the database. If it is there in the cache, then I get it from the cache.
Correct.
But for the other layer, it seems seamless. So in that kind of scenario, we can use the caching server?
I
didn't-
don't understand your question completely. Maybe.
Let's say for a business, let's say business logic is trying to access the data access.
Yeah. So if the
components.
business logic, as long as the business logic has access to our cache APIs,
Right.
then it will work. Then it will be seamless. That is
Okay.
correct. Yes. Like I said, you can actually, right now, if you want to do it, you have to do the PHP to .NET bridge. But in the future, we will support the OData, so you can write any clients of your choice.
I have one more question. So let's say there is only one SQL server behind the caching, and let's
Yeah.
say it goes down,
Yeah.
and you are trying to write to the cache, then
Right.
what happens?
See, the cache is an explicit cache today, right? So you write to the cache, that's it. The cache is fine. Now, it's your application which also has to write to SQL Server. And then it may find the SQL Server is down and not do things, right?
No. I didn't mean that SQL server. I mean the server
We don't
behind the cache.
do implicit caching today, right? So when we do the read through or write behind feature that I said, where the cache actually writes to the backend database, we will have this thing called a write behind, where you can actually queue the data and then write in batches. If SQL Server is down,
Does not depend on the SQL Server at all. There's no dependency on SQL Server.
How about your database?
oh, the config. If you store your config, okay. If your question was, if I choose SQL Server as my configuration database for the cache, we also store some of the lease information in SQL Server. So if the SQL Server, in that scenario, if it goes down, yes, you're right, the cache cluster would have a problem. It won't work. No, if the lease goes out, what will happen is it will try to restart the service, but the services will come down. But then it will restart the service. So in that scenario, if you're using SQL Server as your config store, you should be careful. You should make sure SQL Server has HA enabled. So that's the short answer.
Thank you.
Yeah, thanks.
Is there a limit or recommendation on how much memory per cache server you can use?
Good question. There is no limit right now, but what I have seen from experience is that obviously it's better to have reasonable sized caches in a machine, because otherwise you have garbage collection issues. We are looking at using background GC, but then background GC, so we most likely might give you guys a switch to say that whether you want background or not, because background has throughput problems. So my recommendation is not to have a gigantic cache, not like a 32 gig or 64 gig cache. Instead, maybe have 3 cache servers, maybe each with 8 gigs or 16 gigs. So people have comfortably used, like MSDN forums, they have 8 gigs across 5 machines, so 40 gigs in total. That's no problem for them at all. I've also seen people use 12 gigs and 16 gigs with no issues. The biggest issue comes in Xbox-like scenario, where you are actually putting the machines to extremely high stress. That's where problems come in. If you go into these large kind of memory, if you use 16 or 32, and then you're putting extremely high write ratios, write to read ratios, then what happens is the garbage collection gets kicked in, and then you may start seeing some either timeouts, or you may see latency issues. But one thing, again, to remember, just to add, it's a partition cache. So any issue you would see is localized to that machine, right? So if you're accessing other partitions in the cache, you would not have any issues.
This could be a follow-up for his question. If I want to use the cache for a big search of millions of records, what would be the best practice to use this so I don't hit the database?
If you're saying search, you mean tag search?
It could be a search on, let's say, a car database. I just want to search a model.
Okay, so
and I don't
the-
want to. I want to avoid hitting as much as the database.
Right. So just to answer your question in multiple parts, the cache itself does not provide any search per se, right? You either access it by key, or you can look up by tags. Like the tags is the equivalent of a search, and that's an equality lookup. And it is again a hash index. So if you give us a tag search, all we do is we just quickly look up an index, and then we return you in bulk enumeration. We don't provide search natively. Is
So if
the
I
definition of search.
if I kind of make the signature of the search, make a key out of it, and
Yes,
if
if
the
you can
same
make a
search,
signature of the key, yes, that
if
would
the
work.
same
That'll be
search
pretty
comes
fast.
again,
Actually, a lot of people are using some of the Bing properties. What they're using the cache is they are actually going against other properties to actually grab HTML pages. What they do is they actually make the search key as the key through the cache, and just throw those HTML pages as objects. That absolutely works.
Okay, thank you.
Yeah.
Does it come with any like hit and miss metrics for keys? So
Yes.
for
So
tuning?
that's a new thing we've added in beta. They have the performance counters. It gives you everything
Well,
you
the
want.
perf one's sort of, I assume, across the whole cache. I mean, for tuning, like by key, are we able to get hit and miss metrics?
Oh,
or
by
we gotta,
key. Oh, at the key level, no.
No?
We are giving it
No,
only
miss.
at more like the region or the cache level, saying this is the miss ratio, this is the hit ratio. We're not doing it at the key. Now, yeah, we can't do, even notifications won't help you for that, because we don't have notifications at a miss level.
Yeah.
Is this intended, or is it a viable solution for the object cache, the object context for entity framework in an ASP.NET scenario?
Good question. So for the entity framework, I believe one of the entity folks actually integrated velocity into the object context in some scenarios. I can point you to the links. I don't have it offhand. Actually, it's in the blog link.
In which?
If you go to the blogs.com velocity, I had actually put a link, I think, last month or 2 months ago.
Okay.
So you can take a look on how that works.
Great.
And I know other entity providers, they have actually done that too, integrated with velocity.
Thanks.
And Hibernate has done that too.
Have you done any performance benchmarks against like Memcache?
Yes, earlier, not official, obvious benchmarks. We had run some internal numbers comparable. Obviously, I'm not claiming we're going to beat them. They're specialized for kind of more of read loads. But we are kind of close. I think we were 30% slower or so. But obviously, you have the feature differences and all the other things that come with it.
Okay.
But I don't know the current number. We've not done it in a while.
One of the things with Memcache is that if you add additional, there is really no dynamic scaling at all in Memcache. Because if you add a node, you have to go and update on the client side. It keeps list of all the boxes.
Right. Yeah.
So there is some trade-offs. Plus the other thing is like really, it is a .NET cache versus Memcache.
It's a native
highly
cache,
optimized.
yeah.
You know, like they wrote in C++. So there is a difference.
So we're not claiming that, but what we're trying to be is, obviously, compared to all the other kind of Java or .NET, we are definitely way ahead. So
I think the way that we have seen is that people turn on local caches. So if you turn on local cache in velocity, then your orders of magnitude faster than actually.
even Memcached, yeah.
So the combination of really HA, local caching, and notifications, it just outperforms Memcached. But if you really know what you're doing and then you have highly partitioned data load, somewhat static, nothing can beat that.
In simple terms, though, if I've got a web application, it's got a local cache on all of the app servers, and I've got load balancing, why is this solution going to be better?
Very good question. So question was, if I had local caches on all my ASP.NET, like hash tables or local caches, and I have load balancer, why is velocity useful? The case where it will be useful in that scenario is if the data that you want to cache is a lot more than the amount of memory on each of the boxes. This is the same kind of scenario that Associated Press was running into, right? Second thing, each of the boxes would have to load that same data. Now, if the data is very expensive to load, you're going to have that problem. Like, for example, in
because once you have local cache, then you cannot share it. So if you have shared data, then you cannot just put it only in one ASP.NET process. So
And the third thing we've heard a lot of customers ask is, if you want to make a change, now you have to go to each one of the boxes and do that change, right? Or build some sophisticated system, or like dependency tracking. Whereas if you get the cache server with local caching, that gives you the benefit of both the worlds. You have that shared cache with the faster performing local cache with that notification invalidation. So you get all three.
in some sense, it gives the benefits of like today you have database. The ASP.NET guys also did the same thing with saying that push it to the database, then you can share. But then database, there is latency issues and then the scale issues. So this just mitigates that, by actually creating a cache tree.
Have you guys looked at using the in-state in-proc as a primary and using,
No. The problem is, again, we're looking at some of those, but the problem is if you have sticky routing or not, right? If you have sticky routing enabled, it makes sense to have like the cache as like a backup of the in-proc.
If you don't have sticky routing, then let's say you
have primary versus secondary, right? So
but you won't, then you will read from, then you have to read from secondary.
No, so let's say you have 3 servers. At least a third of the servers can be using their local cache, right?
No, but they can't, right? The problem is you don't know if the next request went to the third server. So you always have to keep refreshing your in-proc cache. Unless you have sticky routing, it'll be hard. But there is a valid scenario where I may turn on sticky routing. I have my local cache, but I use the cache server as like a backup so that if this machine dies, I can still go to something and then have everything in local cache. That's something we can look at, obviously. We have not looked at that. Yes.
Cluster, and then you have your web servers, you can sort of have your primary
Correct. Yes, that is something we have not focused on, but we'll look at that. Thanks.
Just one last question here. In regards to the under the hood, how is the connection working? Can you shed some lights?
Sure. So under the hood, the way the clustering, so we have like several layers in the cache. So the bottommost layer is what we call core fabric, and that's the same as what SQL Azure uses, the same code. And what that provides us is basically clustering. So that's the one opening the TCP/IP sockets and seeing, okay, which machine is up, and it actually then maintains like a neighborhood relationship. It's like a ring. So the neighbors keep watch on each other. So it's not like one centralized guy trying to manage everybody. So it can scale very well. They can scale to thousands of nodes. And so that is a layer, and that provides us the ability to say, okay, this node is authoritatively down or up, right, as the case may be. Then there's a layer above, which is what we call as a partition manager, or it's also called common availability substrate. That's like a thread that runs on one of those machines. And that then uses this information to figure out which machines are up and lets me distribute the partition data across these machines. And that is the one that is maintaining the partition level consistency, right? The logical consistency that says, okay, this machine is owner, so like the primary, and that machine is the secondary for this partition. And okay, if a machine goes down, if the underlying fabric says machine is down, it will say, okay, this machine had these partitions, let me move them over, right? It's providing that replication availability layer. The cache itself is now built on top of that, where it kind of maps the name caches, regions, and everything into these partition concepts underneath. So then the cache layer will give us saying, oh, this partition came up, start a copy process, or like, this is your routing map, for example. We use all that stuff. So that's kind of how it works.
Some of the partition map information, we actually push it to the client. So that's why most of the cases that you just want one hop that from the client you want to get the right server. So it's like your DNS server. So we actually propagate those things, continuously propagate it to the right. So if things change, you may go to the wrong place, but then the server just figures out that, actually I don't have it, just I have it. But it propagates it back to the client, so we actually propagate the routing table information to the client.
And is the partitioning based on a key or based on a server?
Partition is actually a hash range. So we map the keys into regions, and the regions are hashed, and then there are ranges.
The last PDC I gave, that's under the hood part, so there is
okay. Okay. Other question I had, do you have plans for actually compressing or doing some kind of for the values that are being stored?
Okay, we don't have anything right now, but we don't extend the channel. No, not right now. But however, we take byte arrays. So you can actually, a lot of customers have done that. They've done their own gzip on the objects, and they've just given us the byte array to cache. So that works fine, right? All we need is a byte array. Okay. So that would be the current workaround, but we don't have a pipeline kind of integration right now.
Thank you.
Sure.
Hi. Can this be installed on like Windows 7 or Vista Business, or is it only on Windows Server? Like for a developer standpoint,
From a developer standpoint, we'll allow that. From production standpoint, it has to be on server to create out.
Great, thanks.
Are there any plans to integrate with like Unity and kind of use like an AOP style for your AOP like device for caching? So say I have retrieved by ID, and I've decorated with an attribute or set up some intersection, and that'll automatically put it in the cache.
Good question. Good question. Those are some thoughts that we have. We have not like formally crystallized those yet. But that's something we've always thinking about, saying, hey, is it an easier way to kind of annotate the classes to say, just cache them automatically for us. Yeah, that's been kind of our dream, but we haven't come there yet.
We tried to implement it a little bit.
Oh, okay. No, we haven't got there. Any other questions?
Does it provide managerial statistics?
Yes.
For example, cache hits, cache situations?
Yes. So in beta, we have added perf counters. So you can actually look at per second or the cumulative cache hit or miss ratio and so on. Yes, that is available. You have a lot of data, actually. There are like some 40 or 50 counters. Like, you just went nuts. So you can look at everything that you want in the cache, like host level or like cluster level and so on.
Is there a way to override the TCP IP connection timeout?
Yes, you can actually go change those.
So is that per client? Is that what
It will be per
doing?
client, yes, that's correct.
So within 5 seconds?
Correct, correct.
No one responds, then
You can turn it off, yes, yes, that's correct.
I saw how you were, sorry, I'm over here.
Oh, there. It's like, go to watch from there.
I saw the demo of how you had this running in Azure, but I missed the part about whether we can do that now or when.
No, no, no. So we will have a CDP next year.
Okay.
So the way we're looking at it is Azure will provide different VMs, right? So once we have the RTM of this, they will have like a VM that says VM with AppFabric enabled VM, and you'd be able to choose that as a worker role. In the demo that I showed you, I had actually a prototype of Velocity running as a worker role. So I had to upload the server bits also into Azure because Azure hadn't changed anything. Whereas when we come out as a CDP or release, Azure itself will automatically include those bits.
Okay. Any recommendations for us if we're trying to do something like that with Azure right now? Could we use like the old Velocity CTP and create a worker role out of it or anything like that?
Good question. No, you would need to make Velocity sort of embedded. So unless you have code changes, it's going to be hard for that. I have not tried the generic role or the VM role that they have to see if this would work or not.
Okay.
That's something you may want to try, but I don't know. I haven't tried that out myself.
All right, thanks.
No, more for like try out. Yeah, not for live, right? Obviously, you can't go live with that because of licensing issues, but yeah. Right, even, yeah. But now it's 3.5, so beta 1.
I've been working a lot with the CDP3, thank you. I was wondering, how much have you been working with the community and so on to align the API with the normal use of dictionary of T, K, like contains key and add, remove, get? I mean, it seems like a lot of devs have noticed that there's a different experience from using the cache from a normal experience. What are your comments on that? Like track
Are you saying aligning like dictionary APIs with the cache APIs?
Why is Velocity not sort of aligned with the BCL in terms of normal collection
we have tried
usage?
to more align with the ASP.NET with like the system runtime caching APIs because we feel that the dictionary is different from the distributed caching APIs from different standpoints, right? There's a performance.
But I'm talking about the signature of the methods, the API names, and so on.
Oh, the get and put. Oh, okay.
Yeah.
That's going to be hard to change at this moment.
Okay.
But one suggestion that we have for people is to then standardize using the system runtime caching APIs, and then use this as like a provider to that, so that you don't have to, if you don't kind of like the Velocity APIs.
Okay, the CCP3 seemed a little bit inconsistent in it lacked some methods or it forced the developer into some patterns that are
That's interesting.
weird.
So maybe
sort of like
can you send me
create
mail
region
on,
or
sorry,
get region
Sorry?
is fails, right? You have a get region and you have a create region, but you don't have region exists.
We've added
right?
that.
So you have
if
to
I
do a
remember
try.
right, yes.
Blah,
if
blah.
region exists, that was the biggest ask that we always had. So we have an if region exists, actually.
Okay, nice.
Yeah. So if you specifically have comments, please do send it to me.
Yeah, there's a lot of posts on it on the forum, but I'll be there. I'll be at Ask the Experts right now.
Take those into account, but if you, again, have specific, this API is wrong or inconsistent,
Sure.
please do send me, murkris@microsoft.com. So. This is going to be the AppFabric, so it's going to be part of Windows Server. I think they'll announce a formal licensing when they do the RTM. But it is a Windows Server role. Nope, unfortunately. So.
In your presentation, you had an asterisk and you said apart from some HA.
One thing we are looking to see is if maybe the HA feature of Velocity would be in the enterprise edition of Windows as opposed to the standard. So that's the SKU difference, not like a separate product, but more of a Windows SKU difference, potentially.
Hi, I was just wondering, you mentioned that between servers that are doing the caching, it's like a polling-based system?
No, not between the servers. If you use the notification APIs from the client to the server, that is like a poll-based mechanism.
Why is it
Between
not?
the servers, for replication, if you're using HA, it's a proper replication. There's like a quorum protocol and all that
So
stuff.
why isn't it event-based? Why is it polling-based between the client and the
there's another
server?
session? Oh, okay. So yeah, let me step out. We can just congregate over there and talk about this stuff. All right.